So going back to our original function here, we talked about the a, the x, and the c and the d. So we're going to talk about how those affect the graphs. A is still my constant multiplier, or my vertical stretch. C is still my horizontal shift, and D is still my vertical shift. So let's say I give you a function in the form f of x is 2 to the x. G of x then is going to be 4 f of x minus 3 plus 2. So when I'm working with these functions, I always start with my stretches, and then I do my shifts later. So in terms of the exponential function, as an equation, this is going to read 2. The part inside has to go into the x, and 2 to the x plus 2. So f of x being 2 to the x means I can replace f of x minus 3 with 2 to the x minus 3. So we're going to talk about doing this with points and some graphs. Okay. So we'll start with 2 to the x, and then we'll transform that. Okay. And I'm going to do it piece by piece, and I'm going to graph it. So 2 to the x, 2 to the negative 2. I believe we've discussed this already, but the negative exponent moves it to the denominator. This is going to be 1/4. So we're going to see a pattern here with a 2 to the x of doubling. 2 to the negative 1 being 1 over 2 to the first, 1/2. Double that, 2 to the 0 is 1. 2 to the first is 2, 2 to the second is 4. So I'm going to graph this quickly right here. And we're going to see that the graph of our exponential function kind of looks like this swoop curve and has this asymptote along the x-axis. So here's my 2 to the x. Now we're going to do 4 times 2 to the x. This, the vertical stretch, does not in any way affect my x coordinates. Okay? And so I'm just going to multiply each x coordinate by 4. 1, 2, 4, 8, 16. So now I'm going to graph this one. And we're going to see that what's happened to this is I've simply stretched this upward. Okay. Not a big change, but I just pulled it upward. It's much steeper now. It's a little hard to draw nice graphs, but feel free to plug it into Desmos and see that if you would like. Now when I do my translations here, now I have to shift my x and y coordinates to do my translations. So I know that this undergoes a shift to the right 3. Again, opposite the sign, so I'm going to the right. So I take my x value and I shift it to the right 3. I'm here at negative 2, I go right 3, 2, 1. I take this value, this is already my 4 multiplied by 4. So I multiplied my y coordinate by 4. and then I'm going to add 2 to it. This one shifted left 3 is 2. This one up 2 is 4. So I'm just taking these, breaking them down, just adding a step. Here I added 2 shifts. And I think you can handle that. 3, 6, 4, 10, and 5, 18. Okay, I'm gonna make my 10 a little neater. And that looks a lot like a 16. So again, I've taken each point, left 3, up 2. Take this point, left 3, up, no, right 3, up 2. Right 3, up 2. I went too far on the last one. Right 3, up 2. Right 3, up 2. There we go. Right 3, up 2. And I gotta go one more. Right 3 over here, up 2. And I'm gonna get roughly the same thing. The other thing I need to do is as I shift the graph up 2, I need to move that asymptote up 2 with me. Okay, so we're going to look at doing this with some points and doing this a little bit with some graphs. Okay, so again, the transformations don't change, but I kind of got to do it my key points. And I'm definitely going to need to graph this before I try to graph this. So I kind of need to do this in steps. I'm graphing my 4 times 2 to the x before I graph my 4 times 2 to the x minus 3 plus 2. You may not need to graph the 2 to the x every time, but if it helps you, please do.